Sonia, what are you doing today? This is looking pretty interesting out here.
Hey, hi, Aaron.
Yes.
How are you? Please sit down. Have a seat.
Oh, thank you. Hey, it's just something I saw around and I thought I'd have a look at it.
Yeah, I'll explain it to you. Okay, so this is a Xoriant IoT lab, and we are working on a project for a client called Automaton in the IoT space.
So IoT, you're meaning Internet of Things?
Yeah, you got it right. So it's like connecting the things together over the internet to make big scale projects like smart cities, smart farms, smart parking, even a smart home.
How interesting. So how do you do that? How do you make homes smart?
Okay, so there are many solutions available in the IoT space for making these smart projects, and we are using one from our client called Automaton. The platform is called TQL.
So TQL, doesn't it sound very close to SQL? Is it similar?
No, it's not similar to SQL, though it sounds familiar. So TQL stands for Think Query Language. So it uses the various queries to get the data from different kind of things, which we call in IT space sensors and actuators.
Go. So you said sensors, actuators. So can you give me a little bit of idea of how exactly this all is getting used?
Yeah, sure. I would like to show you something with a simple diagram on a whiteboard. That will do?
Yeah.
Okay, let's see that. Now let's look at our hardware setup. We have got 3 machines over here. These 3 machines are running 3 different flavors of OS. We have a Raspberry running Raspbian, we have a Windows machine, and then we have a Linux machine. Now on these 3 machines, we are running 3 instances of TQL engine. TQL engine is great for independent, so you can just run them on any OS. Now let's look at the first machine. This first machine is called Sense and Load because it has an Arduino connected to it, which in turn is connected to a proximity sensor as well as a temperature sensor. Arduino boards reads the data from the sensor, send it to the TQL engine, which over the web socket passes it to our controller node, which is the master node. What this controller node does is to send these values to the actuator node. This actuator node again have an Arduino connected to it, which is connected to 2 actuators, that is a LED and a servo motor. There is yet another actuator connected to the machine, which is a USB camera that is directly connected to the Linux box. Now coming back to the controller node, which acts as a mediator between the sensor node and the actuator node. There are 2 functionality of this controller node. One, it runs the application UI, which will be used by the smart home owner to control the different sensors. This API has been deployed on the TQL engine using the static file sharing feature. Also, it is contacting an open weather public API to get the temperature from the outside world. This is how it looks on the board. It's all simple. Now let's see how it looks in the actual circuits. Let's look at the actual circuit of our sensor node. So here we have a Raspberry, which is connected to an Arduino board. This Arduino board is connected to 2 sensors. One is a proximity sensor, and then here we have LM35 temperature sensor. Now this is the hardware setup of our actuator node. The actuator node is connected to this Arduino board, which is connected to an LED, and then it's also connected to a servo motor. So as we can see, here is an actual servo motor. Then here we have an LED, and then we have a USB camera.
Now we have seen the hardware. Next, my partner Samyak will be giving you more details about the smart home project.
Hi, let's see it on the whiteboard.
A smart home is divided into 2 sections, or you can say 2 models. First is a smart garage and second one is a smart home. So, smart garage consists of a IR proximity sensor and 2 actuators, which are servo motor and USB camera. When IR proximity sensor detects any object in between its range, it provides a signal. That signal we capture and it sends it to the servo motor. And when it triggers the servo motor changes its angle and opens the door. The second actuator, which is the USB camera picks the image and tells us who came into your garage. Let's look at the second module, the smart home. In smart room, we have used the LM35 temperature sensor. It detects the temperature and humidity. Out of those, we are using only temperature here. So when temperature sensor gives a signal, we change the color of the room ambience according to that. For example, if room temperature is below the 18 degree, then we show it as a blue light. If it is between 25 to 28, we show it in the room, it's a white light, and if it's above the 31, then it's a red. So these are indicators to show what are the room temperatures currently in your smart room. At this things in action.
This is our physical model and this is our UI through which user is going to control our smart home.
Let's look at our models of our smart home. This one here is a garage model and this one here is a smart room. Let's look at our garage model. You can see here there is no image in our garage section. You can see here date and time. So let's simulate it. Whenever any vehicle enters into your garage, the proximity sensor which is outside your garage door will detect the vehicle and then it will click the image. Once the image is clicked, the garage door will get open, the vehicle will get inside the garage and then door will get closed. And you can see the changed image on our UI also. Just look at our smart room simulation. You can see here current temperature is 26.37, which is the room temperature, and other temperature, outer temperature is 23 degree, which we are getting from our HTTP client web service. Let's simulate it. So I will tell you the expected behavior. Now you can see here it is a white light because the temperature is normal room temperature, which is between 25 to 28. Once the temperature rises above the 30 degree, it should turn into red. You can see on the UI the temperature will rise. Yeah, now it's 29, 30, 31. See the red light. And if I remove my hand, then it should again go down to room temperature and it will change its light to the white light. It turns again white.
So, was this really fun and challenging for you guys to get done?
Yeah, the challenging part was there and fun was also there. If you look at the challenging part, have you seen these sensors and all? This is a kind of a crazy stuff. If you need to learn those things, you need to spend much time on the internet and to learn those things. And fun part, she will explain you the better.
Well, as we had some hard time with hardware and we had some soft time with software when it comes to the TQL. So once the hardware was set up, it just took us a few days, I guess, to make it all working on the TQL. And it's kind of a sense of accomplishment when you do something from end to end, learning something new entirely and seeing it work.
Great work, guys. I mean, this is absolutely awesome. So good work, Neha. I think I'm looking forward to seeing much more things in this area. Smart homes and everything. It's really great to see. Looking to see what next is there in this.
Sure, there will be more. I promise you that.
Thank you.
Thank you.